Hello, welcome back. In this series of videos, we're building a small sample Microsoft Access database application to handle time and billing for customers. This is actually modeled, as you know, on the time and billing database software that I use in my own practice as an Access consultant. The final result here will be somewhat different than the one I actually use, but as we go through the process, I'll explain some of the decisions I made and why I made them the way I did. The idea here is not to get you to copy or duplicate what I did, but to get you to think about design issues, both from the point of view of the technical side, the normalization side, and the business rules that constrain and guide how we implement our database in order to meet the needs, the business needs of a particular organization. So it's always a case where we're trying to balance those two factors. I was going to go ahead and start adding additional tables today, and then I thought, you know what, it's probably a good time to pause, do a summary and review of what we've covered so far and see if we can maybe elaborate a little bit on some of the technical things that we have looked at, and also to sort of reinforce some of the philosophy, the design philosophy behind what I do when I'm building a new database like this. So let's start by looking at our original assumption here, which is that tables. We're going to start working on tables in every new database we build. That's just a fundamental principle that we always follow. But there's a good reason for that. And as I tried to use the analogy of a house with a foundation, the reason we want to make sure that our tables are built first and that they're correctly designed according to both design principles from normalization and from acceptance, or not acceptance, but accommodation of the business rules that govern what we do. And when we design and build our tables that way, we have a strong, stable structure on which to build the rest of the database. Now, the way you build the tables determines whether the structure is strong and stable. Those two things go hand in hand. A stable foundation is stronger than one which is not stable. But you also have to have enough strength in the right places to handle the load that's going to be placed on it. So a second part of that is not just the stability, but that the design is appropriate and adequate to handle the data load that will be put into the database. And then you have a strong structure. But there's another way to look at it too, and that is to look at it in terms of the function, or how those tables are used, not just whether they're built correctly, but how they're used. There are a couple of key factors that we started to look at here. One is the roles represented in the tables. And as I was thinking about this particular point, that's when I realized we probably should stop and review the tables we've built so far in light of this concept that the tables all have particular roles or functions. They do certain things for us. And some of those, as we saw last time, are just to hold lists of items that we want to track. But there can also be tables that do other jobs for us, fill other roles. Lookup tables, for example, are an excellent way to supply a standard list of options for a particular attribute or the characteristic of a particular entity. So we also have to look at tables in terms of the roles that they represent. And in addition to that, we have to understand the interaction or the relationships between those tables. And to go back and rely on some of the things we've looked at so far, we can say that a customer is located at an address. So there are two tables represented there. There's the customer table and the address table. And between them, there is this relationship. Customer located at, that's the relationship description, is located at, and then the address. So as we're building our tables, we also have to keep in mind that they need to relate to one another. We need to build our tables, design our tables in such a way that it supports those relationships and in turn makes them stable and strong. But then as I was looking at this, I got to thinking, okay, roles, and I'll come back to this point later in this video, but is a table properly defined as a noun, an entity, a thing, or is a table more like a role or a function that a particular entity or thing plays? And I will be looking at the customer table in light of that consideration. Second thing I thought, okay, as you know, I really like to use analogies to try to explain how things work, because I figure if you start with something you are familiar with, it's easier to draw a comparison between that familiar to something new and understand a little more quickly or a little more clearly how things in this new field of study might work. So one of the ways that I like to analogize a database is to talk about it in terms of a database language as opposed to a natural language. So for example, in a relational database, the language is built around nouns, adjectives, and verbs. Whoa, a little bit of a hop in my cursor there. Nouns are the names of things. And so everywhere you look, you see things that are of interest to you. And they generally have names, but customer and address are two that we've used so far. The customer is the name of a thing that we're interested in. Address is the name of a thing that we're interested in. So those are both nouns. They name things. Adjectives describe nouns. And just the same way within a properly designed relational database, the attributes or additional fields we append to a table help us to describe those things. The main difference is that within a database where we have limited resources, limited storage, we only want to track attributes of importance. So the adjectives we use to describe our entities need to be relevant and important to the purpose of this particular database. And I'm thinking, for example, of an address. One of the important attributes of an address is the street on which it's located. Main Street, 131st Street, Melrose Avenue. It's probably not important in most situations whether that location is a brick building or a stick frame building or steel high-rise. What's important is where we find it. Now, there are other types of applications, perhaps, say, an insurance, a fire insurance application, where indeed that construction material is critical to understanding the risk. A stick frame, a wood frame building is exposed to a higher risk of fire than a steel and glass building might be. So it depends on the purpose of the database, what attributes are important. And those are, again, the fields that you include in the table as ways to describe that particular entity or thing. So in a natural language, that would be the corollary of an adjective. The third way we can say that a database talks about data is in the verbs. We have the things, the attributes of those things, and what they do, how things work. We've so far looked at only one, really. That is the relationships between two things. For example, a customer uses a phone number, or a customer is located at an address. That's the primary kind of relationship verb we have encountered so far. But you can also say, for example, a retail store sells products, and so the relationship there is the sell. One sells the other. Or you could reverse that and say the product is sold by the retail store. So there are all kinds, bill, anything you can think of that would convert to a verb in a natural language could potentially be a relationship between two entities, between two tables in a relational database. So that would be the three parts that we're interested in of a natural language that have counterparts in the database language: the nouns or the names of things, adjectives or important attributes, and verbs or the relationships, how things work one with the other. There's still another way in which we can talk about how tables work in a database. We've talked about the structure and the function of those tables. We've talked about the language, the natural language corollary of nouns, adjectives, and verbs that table design provides for us as a way to talk about data. There's still another way to think about tables, and that is to consider how they're constructed, what's in them, what kind of information do they contain. So far we've identified three of those types, the first being the lists of members, or just lists of things. They're typically members of a group, and we had a couple of those so far, one for customers, one for phone numbers. We had a third one for email addresses and one for phone numbers. Email address, street addresses. Phone numbers, street addresses, and email addresses. So we have a number of different list tables. They're just lists of entities along with the attributes that are important to track about that particular entity. We have a special kind of table called a lookup table. And a lookup table is really a way to package up attributes, one particular attribute in each table, in a way that allows us to reuse those common attributes over and over where appropriate, without having to re-enter, retype the actual value. We looked at phone type, where we had a small closed domain or set of values for phone type, and we also had one for priority. It's a small closed domain or set of values: primary, secondary, other, and inactive. These lookup tables are different from the sort of list tables, in that a list table is open-ended. You can continually add new records to the customer table as you acquire new customers, and so on. Lookup tables, on the other hand, tend to be more static. If there's a change in one, it's because there's been a change in business rules, perhaps, or because we've identified a new type of, say again, a street address or a phone number type that we want to track separately from others of that same category. The third type of table we've looked at, I think of as relationship tables. And relationship tables are essentially the many-to-many junction tables that allow us to indicate how two entities interact one with the other. Customer phones, for example, is a junction table which relates one or more customers with one or more phone numbers. So one customer can have multiple phone numbers. Each phone number can be used by multiple customers. So the relationship is codified into that table. Customer uses phone, or customer has phone, and vice versa. Phone belongs to customer. There are other ways we can create relationship tables depending on how that relationship works. For example, in a retail environment, you might have a relationship between a product and a customer. Product is sold to customer. And so you would have a table set up that would manage or track that sold to relationship between products and customers. In a construction or manufacturing context, you might have something like a build, where a contractor builds buildings, or a factory manufactures washing machines, for example. Anytime you have a situation where two entities interact in some way, one with the other on a specifically defined parameter, you have the potential for a relationship between those two tables, and you can manage that within the context of either a many-to-many relationship table or a one-to-many relationship table in the database. There's another type of table I'm going to show you in the next video. It's very similar to a relationship table the way I just described it, but it has one additional feature that, in my mind, allows me to separate it out from a straight relationship table. That concludes our kind of review and summary of what we've looked at so far. We talked about how a good table design provides a strong, stable structure, foundation for your database. Stable meaning you don't change the way tables are designed very often. Strong meaning they are capable of supporting all of the data needs that you have, or all the ways you need to store and track data are easily accommodated by your structure. We talked a little bit about the fact that tables work together. They fulfill roles, and we talked about the three types of tables. It's a different way to look at that same role or relationship between tables. We looked at the analogy to a database language. We have nouns, which are the names of things. We have adjectives, which are the attributes of importance, which are fields in a table. We can do that directly in the parent table, or we can do that as a lookup field to a lookup table. We talked about the way the relationships in a database correlate to verbs. So the natural language scenario would be nouns, adjectives, and verbs, tables, attributes, and relationships being the database language. And then we broke out our types of tables again a little bit differently. This time we talked about how they work, customers and phone numbers, email addresses, and so on being lists, essentially. Lookup tables are a very special kind of list table, small, closed domain that we can use over and over and over to provide attributes to members of a list. And then we talked about many-to-many tables, the junction tables, where we have the relationship identified between one or more items on one side, one or more items on the other. In the next video, we'll move on from here. If you like what you've seen so far in this video series, please subscribe. Use the subscribe button on YouTube to subscribe to our videos. Also, if you want to provide feedback, I'd be happy to either expand or explain in more detail on any point brought up so far. And if you have suggestions about things you'd like to explore in more detail, I appreciate that as well. So for now, we'll wrap it up. I'll see you in the next video. Thank you.